Elon Musk has long been vocal about his vision for a future where humanoid robots are seamlessly integrated into everyday life. He once posed a simple question: who wouldn't want their own personal C-3PO or R2-D2? But even better, that idea, which once seemed like something pulled straight from the realm of science fiction, is now rapidly approaching reality with the unveiling of Tesla's Optimus Gen 3 humanoid robot. Musk's goal is not just to impress tech enthusiasts or attract investors, but to deliver a practical, human-centric robot that genuinely serves the public by relieving people of daily burdens and physically demanding chores. What once felt like an ambitious dream is becoming a stunning new chapter in how we relate to machines. With each iteration, Tesla's humanoid robot gets closer to being something not just seen in tech expos, but living alongside us at home. Optimus Gen 3 represents a major leap from previous prototypes, moving us beyond clunky experimental bots and toward a true household companion that could assist the elderly, help parents with children, or even become a lifestyle upgrade for busy individuals. For many people, daily household tasks are more than just tedious. They can become a physical strain. As people age or develop medical conditions, even simple tasks like crouching, bending, lifting, or carrying can become painful or outright impossible. A robot assistant that never sleeps, never forgets, and never needs a break is no longer a fantasy. Tesla's Optimus Gen 3 isn't just another flashy tech gadget. It's a fully functioning assistant equipped with artificial intelligence, learning capabilities, and physical finesse that brings it eerily close to human ability in many practical domains. This new model comes with an attractive price tag, one that's lower than many high-end phones, and offers a level of autonomy and support that previously didn't exist outside of science fiction. When Tesla introduced Gen 2, the world took notice, but it was evident that it wasn't the final form. Gen 2 was an early prototype useful for testing concepts, but not robust or capable enough for widespread use in real homes. Optimus Gen 2 had several impressive features for its time. It possessed 22 degrees of freedom in its hands, allowing it to open and close its fingers, grasp light objects like plastic cups, and even pour liquids with roughly 85% accuracy in lab environments. It could also sweep crumbs from tables and perform other simple tasks with a success rate of around 70%. It moved at a modest pace of about 5 kilometers per hour, the speed of a brisk walk, and was capable of carrying weights up to 10 kilograms, which meant it could help with smaller household tasks. But the robot's limitations quickly became apparent in real-world conditions. Gen 2's fine motor control was lacking. It struggled with tasks that required precision under 1 millimeter, such as threading a needle, handling buttons, or sewing fabric. The absence of tactile sensing made it impossible for the robot to differentiate between soft and hard objects, leading to frequent errors when trying to pick up delicate or irregularly shaped items. Its balance system was another glaring flaw. The robot could walk on flat surfaces, but anything beyond that, stairs, slopes, or uneven flooring, became a major challenge. During testing, it failed more than 40% of the time when trying to climb steps or navigate tilted surfaces. The inability to kneel, crouch, or pick up toys from the floor limited its usefulness in real households where such movements are essential. Moreover, Gen 2's object recognition capabilities were limited to a database of about 100 items. Anything outside that predefined list required manual reprogramming, which made adaptations slow and cumbersome. Its reaction time was also sluggish, with an average latency exceeding 500 milliseconds, meaning it often responded too slowly to avoid obstacles like a fast-moving child or pet. In essence, Gen 2 was never meant to be the endgame. It was an important stepping stone that laid the groundwork for the far more advanced Gen 3. The Optimus Gen 3 robot is not just an upgrade, it is a complete reimagining of what a humanoid robot can and should be in a household setting. Tesla's engineers redesigned every aspect of the robot, focusing on 3 core areas: physical dexterity, mobility, and cognitive intelligence. Starting with the hands, Gen 3 now includes 25 degrees of freedom, pushing it closer to the natural range of motion found in the human hand. This allows it to perform intricate tasks like threading needles, tying shoelaces, sewing garments, folding laundry with precision, and even sorting pills or screws by size and color with over 90% accuracy. The enhanced articulation in the fingers and wrists gives the robot near-human finesse, enabling it to handle delicate objects, button shirts, peel fruits, and manipulate tools with measured, deliberate movements. Tesla has also introduced advanced tactile sensing into Gen 3's hands, giving it the ability to feel through a combination of material recognition and force feedback. This means the robot can detect the softness, texture, and resistance of objects in real time, adjusting its grip strength accordingly. For example, when holding a sponge versus a glass or plastic object, the robot understands the difference and applies the appropriate pressure without being explicitly told what it's holding. This prevents mishandling or breaking delicate items, and ensures safety around children, pets, and other fragile items in the home. The tactile system even allows for the detection of resistance during motion, meaning it can feel when it's encountering friction or tension while scrubbing surfaces, twisting knobs, or sewing through thick fabric. Mobility is another area where Gen 3 shines. It has been equipped with upgraded actuators that are lighter, faster, and more energy efficient. The robot now walks with greater balance and fluidity, thanks to dynamic foot sensors and gyroscopic stabilization. It can climb stairs while carrying up to 20 kilograms, double the weight capacity of Gen 2, and maintain a stable center of gravity even when crouching or reaching under tables. Its walking speed has increased to over 7 kilometers per hour, approaching a human's natural brisk walking pace. This added mobility means it can navigate tight spaces, uneven floors, or even outdoor terrains with more confidence and reliability, opening the door for broader applications outside just the home. Perhaps the most transformative feature in Gen 3 is its brain, Tesla's Neural Network 2.0. Unlike traditional robots that need painstaking manual coding for each new function, Gen 3 learns by watching first-person video footage of humans performing various tasks. It can mimic those routines with over 95% accuracy and can automatically adapt to new surroundings without being reprogrammed. This means if you rearrange your living room, move the coffee mugs to a different cupboard, or replace your furniture, the robot doesn't need a software update to understand the change. It learns on the fly, allowing Gen 3 to interpret natural language, facial expressions, and emotional cues. This adds a layer of emotional intelligence, letting the robot respond with empathy and context. Asking it to do something feels like talking to a person. It understands tone, can sense urgency, and learns your preferences over time. Voice control is built in, and no technical knowledge is required to get it started. Despite all these capabilities, one of the most astonishing things about Gen 3 is the price. At just $5,790, it undercuts not only competitors in the humanoid robotic space, but also many consumer electronics like laptops and smartphones. Tesla achieved this price point through strategic reuse of its EV hardware. Instead of designing everything from scratch, Tesla incorporated proven components from its Model 3 and Cybertruck lines, including AI chips, electric motors, and vision sensors. This hardware reuse slashes production costs by up to 40% and ensures high performance without the typical overhead. Moreover, Tesla manufactures Gen 3 robots in the same gigafactories that produce its electric vehicles. These massive facilities already operate at high volume and efficiency, allowing parts like limbs and torsos to be made using gigacasting machines that maximize output and minimize waste. Tesla also benefits from having thousands of Gen 3 units already deployed internally across its factories. These robots are used for quality control, logistics, and repetitive manufacturing tasks, which accelerates development, helps iron out bugs, and drives down error rates by over 50%. Real-world usage is feeding valuable data into Tesla's AI systems, allowing for rapid iteration and continuous improvements, something no other robotics company is doing at this scale. The cost savings extend to software as well, because the neural network learns from billions of hours of video rather than relying on code. Tesla avoids the massive expense of hiring large software engineering teams, and since all robots benefit from the collective learning of the entire network, Tesla can spread development costs across millions of units. The company's long-term goal is to produce millions of Gen 3 units by 2030, This scale alone is expected to drive prices down even further. Analysts predict that within the next few years, Tesla will be able to sell humanoid robots for under $5,000, making them not just accessible, but common in households around the world. This kind of mass production, enabled by a combination of vertical integration, hardware reuse, and real-world deployment, is something competitors simply can't match.